Continuing on the process of transport, for MCQ 4, we will be taking a look at a sequence that is very much relatable to osmosis. So a few key clues here given here is that after the 20 minutes mark, there's actually a change in the volume of the whisking tubing content. So it could go up or it could come down. So whenever it comes to the act of changing in whisking tubing volume, it always has to be relatable back to the process of osmosis. So a whisking tubing itself is going to be partially permeable. And this partial permeability of the whisking tubing means that they allow us to have a difference in water potential between two regions. So if let's say you see that there's a high water potential on the outside, if it was immersed in such a solution, which we can otherwise say that this was a hypotonic solution, that would mean that the movement of water will actually be into the whisking tubing via the process of osmosis. And definitely what we will see it later is that the volume that is found inside the whisking tubing, it will actually becomes much bigger because there's more water that's actually entering itself. Now, of course, if let's say we are dealing with a lower water potential solution that the whisking tubing is submerged in, which we call this as a hypertonic solution, water will actually then be moving out of your whisking tubing via, again, same process of osmosis. And if that's the case, we should see that the whisking tubing should actually be shrinking in size after a while. Now you see that in solution 1 and 2, we are given terms like sucrose as well as water. Now a little trick here that I often tell my student is that if you're dealing with water, we're just going to assume that it's going to be at 100% water potential. Now for the case of sucrose solution, we're just going to take 100 minus the percentage of sucrose solution, and that will actually reveal to us the water potential. So at a 5% sucrose, I would say that this is of a 95% water potential. 5% sucrose is again going at 95%. 10% sucrose is 90%. 10% sucrose is 90%. 15% sucrose is going at 85%. And lastly, the 5% sucrose in option D, solution 2, is going to be at 95%. Now, since solution 2 is actually the contents that is found in the whisking tubing itself, now let's check. If we want the whisking tubing to shrink, that must have meant that solution 2 was of a higher water potential than solution 1, causing water to leave the whisking tubing via osmosis. But should we want the whisking tubing to actually shrink? My mistake. If we want the whisking tubing to actually increase in size, we want solution 2 to have a lower water potential as compared to solution 1, so that water will enter the whisking tubing via osmosis. So in A itself, solution 2 is actually 100% water potential. Water is actually going to leave the whisking tubing. However, A is wrong because it stated that the change in the volume of the tubing increased where it should actually decrease. Now for B itself, 90% for solution 2 and 95% for solution 1 means water will enter by osmosis. And yes, B is actually the correct answer because the volume increased. Now continuing with C and D, you see that water is also entering for C, but yet it actually decreased. But for the case of D, water is actually entering as well, but yet it also shows a decrease. So once again, osmosis is all about understanding the kind of solution you're dealing with, and you are given percentage of a kind of solution, take the difference between that of 100 and that will be its hypothetical water potential.